Alrighty, time to start a new streak. I thought about the last hard one, and I didn't give it much time, but I didn't come up with anything else. So another one for the to-do list. Anyways, easy. Find resultant array after removing anagrams. The resultant array after removing anagrams. Okay. If you're given a zero-index string array words, where words I consist of lowercase English letters, in one operation, select any index I such that 0 is less than I is less than words.length, and words.I minus 1 and words.I are anagrams, and delete words.I from words. Keep performing this operation as long as you can select an index that satisfies the conditions. Return words after performing all operations. It can be shown the select indices for each operation in any arbitrary order will lead to the same result. Anagram is a word rearranging the letters. Okay. So ABBA, BABA, those are anagrams, so you delete ABBA. BABA, BBAA are anagrams, so you delete that. So you're left with BBAA, CD, and CD, they're anagrams. So BBAA, CD, nope. Okay, I misread that. You delete the later index, later value. So delete this, left with that and that. Okay, so I guess the main thing is whether or not two consecutive words in the array are anagrams. What is the best way of detecting anagrams? I guess this is not very long. What is the best way of detecting anagrams? I guess you could sort. Oh my god, you can sort it. Sort the letters in the word and compare the sorted words. I guess, maybe. Okay. Sorted words is gonna be I think if I do a particular word dot sort, I don't think that works. Maybe I can actually do something like for every word. No, I don't think that works. Sorted words equals sort of the word for every word in words, maybe? I think that might be the syntax. What is the sort function for words? Sort Python. List.sort. Guess the string is not a list, huh? Or I guess maybe list.sort. Yeah, it doesn't apply to a string object. Oh, it's sorted. Oh, maybe that's what I was thinking of. Sorted. Okay, and I think maybe I need to convert this to a tuple because I don't think I can compare lists like this. So maybe tuple of that. Well, maybe, I actually don't know. I don't think I can compare lists. As in, I don't think I can do something where I say for every index in range length of words minus 1, print same if sorted words at this index equals sorted words at index plus 1, print same. I don't think this works. So I think this would be comparing. It does work. I thought this would be comparing the memory pointers of the lists. Quality comparison lists in Python? I don't know. The equals operator checks for exact equality between two lists. This means it returns true only if they're same length, same element, same order. Element-wise comparison. If you need to compare the list based on criteria other than exact equality, you might use method. Okay. Okay, I guess that's just not what I was expecting. So in that case, what I would want is to keep track of the index, the first index maybe. So index equals 0 and equals length of words. So I have an answer array for every, let's say, while index less than n. Maybe I need to have a current index. Maybe I need to have a current index. Maybe I need to have a previous index. Previous index is maybe -1. In which case I need to have a sorted words that is unique. No, maybe I can just have this and have index start with 1. While current index is less than n, if sorted words at the previous index equals sorted words at this index, this current index, then current index is incremented. Else answer should append. So it's going to be comparing this and this, they're the same. Compare this and this and this, they're the same. Compare this and this, they're different. So then I should add this to the answer. So sorted words at the previous index. And then make the previous index the current index. And I think think I always increment the current index at this point. So I should make this not equal. Refactor this. Okay, so if the current index, if they're not the same, if they are the same, then all I do is increment the current index. And if they're not the same, then I need to add to the thing, add to the answer, move the previous index to wherever the current index is, which skips over a bunch of stuff maybe, and then increment the current index. Okay, and then how would it handle the ending? I think it handles the ending. Does it handle the ending correctly or incorrectly? So if the previous index is moved to the last valid index, current index moves to the end, then what? So how would it work here? Let's say this thing is here, this thing is here. I guess I need to append the final value if that final value is actually the last thing in the array. If it's not the last thing in the array, then it somehow skipped over. Skipped over a duplicate. No, I think I always append the last thing that the previous index is. Oh, this should be appending whatever the actual word is at this index. Okay, I think this is correct. Maybe I misspelled some stuff though. Okay, I didn't. Could be too slow though. Okay, it is kind of slow. It is kind of slow. I think it's slow because of the sorting. How else do you do it besides sorting the letters? Sorted of the words for every word. I guess in theory, instead of doing a sort, you can, well, how long is each word? You can make a histogram of the number of letters. So you convert each word into a 26 times tuple maybe. That's the frequency of the letters in the word. Is that faster or slower than sorting? (26 times tuple). So like AABB would become like 2, 2, and then 24 zeros. CD. What is the quickest way to compare two words to see if they're anagrams? Guess I can do a counter object. The objects being basically the frequency. Two counter objects are considered equal if they contain the same keys with the same corresponding counts. Okay, so I mean that's the same. That's the anagram. Okay, so let's go ahead and just try that. Counters would be counter of the word for every word in words. Guess I use pretty much the same code here, except using counters instead of sorted words. So oh, shucks. I don't know why this didn't work. Counters, counter, and I think that's it. Oh, I should return the answer here. Oh my lord. Okay, okay. That's definitely a... What's the opposite of improvement? That's definitely a... What's the opposite of improvement? Deterioration. That's really not what I'm looking for. That's definitely just worse. Strictly worse. Okay. Sorted words. This is supposed to be easy. I guess in theory this would be this. I guess it's not medium. Previous index, current index. By rearranging the letters of a different word or phrase using all the original letters exactly once. Sorted of the words for every word in words. I guess I don't need to maybe create a separate list. I could just do sorted of this thing. Maybe I start with previous, the sort previous is sorted of words at 0. And then I probably always need a current, sorted current is sorted of words at the current index. And then I just compare these. The sort previous and the sort current. Append the words at the previous index, increment, move the counter or move the index, move the pointer, increment the pointer at the previous. Okay, I think this might, I mean, it should be the same amount of work, really. Wow, doesn't work. Huh, really? So it's giving me 2 CDs. Why would that be? Oh, whoops, I forgot to do, I need to update the previous index and the sort previous equals the sort current. Okay. Okay, so I mean, the list comprehension, even though I think in theory it's the same amount of work being done, I guess the memory usage of storing it as a list makes it in well, it does make it take more space, but also takes time to make that memory. I think this is as close as it's gonna go. I think this is as close as it's gonna go. I have to make a sorted version of each. While current index less than n. Wonder if I can make a dummy value so that it doesn't do that. While current index less than n. No, I think that's fine. It's basically a for loop. Actually, it is a for loop, isn't it? What am I doing? I'm incrementing the current index one each time. For current index, I guess even then I'm just iterating over the actual values. Okay. No, I need to know the index because it needs to update the actual index here. Okay, yeah. For current index in range of 1 to n. And then I can remove this. Get the sorted version of the current value, current word. If it matches, if it doesn't match, then update the answer, update the indices, update the previous sorted word. Okay. I mean, it's the same as the while loop. I mean, I expect no difference in speed. Maybe it's slower just for variance, but yeah, it's just slightly better. Slightly better presentation. Wonder if I can do without the previous index. Yeah, okay, that's it. So summary, this is going to be kind of a 2 pointers to track the current or to track the last unique word. This is with the previous, which is going to be at the previous index, and a current index that is after it to compare if the words are anagrams, if the words at those indices are anagrams. Sort, compare the sorted version of those strings. So for example, comparing ABBA and BABA, comparing. For being anagrams, compare the sorted ABB versus AABB. Move the pointers appropriately when detecting non-anagrams. Basically, move original word from words array to answer, and then update the previous to current. And then, yeah, just careful with fence post issues. So here I had to add the final word at previous index to answer, since otherwise there's no comparison, since there is no anagrams for that value. Or actually, since there is no point in the loop where that last original word is added to the answer array. Okay. Time complexity, this should be O of n, since the 2 pointers iterate over the n indices at most once. It's incrementing 1 each time. The previous index might be jumping over some certain indices within the n, but the current index definitely goes through all n values except 0. And then, oh, wait. Except since sorting is done each loop, what is the length of the strings? Words.length. And strings can be long in theory. It should be O of n times k log k, where n is the length of words and k is the length of each individual word. Space complexity, this can be O of 1, since, or O of k, I guess. Yeah, O of k, since we're storing the sorted words. Well, like the sorted current word and the sorted previous word.